If you look at the DBShift, tool that we have, it's fundamentally have three building blocks, and starting from the assessment. So we have this automated assessment which goes and scan the data warehouse, the source data warehouse, and looks for the objects, candidate objects, in fact, which needs to be translated to the target. Now, it could be including the table structure, it could be the constraints on the table, relationship between the tables, all the way to the triggers, views, ETL script which has been written, like a stored procedure and things like that. Now, these are the candidates, which is something which needs to be migrated from a source data warehouse to the target data warehouse. So it's always crucial for, before the start of the migration project, is to assess the complexity of all these objects so that you can do the right sizing. Right, and also give kind of like an assessment or a risk report to the customer upfront that, hey, what will it take to do the migration. With the generative AI capabilities, we are able to do these scorings pretty automatically. Like, we are actually assigning the scores for each of these objects that needs to be migrated, and we kind of like create a assessment report saying that what portion of these overall objects will be migrated by the AI, and what might require some level of human interventions. So that is the first part of the DBShift tool that we have now with generative AI. The second, the most crucial part, which is actually the core engine of the DBShift with generative AI, is the migration. Now, what we have done here is that we have taken a foundational large language model, and we have used this model to and if I can talk about a little bit of a foundational large language model, the model was already having a good SQL understanding, if I could say. Now, what it was lacking is that, specification, for example, for a given source and a target. Like, for example, if you're having a Snowflake and a Yellowbricks as a combination, Snowflake is the source and Yellowbricks is the target, and the vice versa. The semantics or the syntax of these specific databases was not there right away from these foundational models. So we had used our, as I said, like deterministic mapper that we had as one of our IP to fine tune these foundational models to get that level of missing understanding of this database specific skills. And after we did that, did the trick for us to do the migration for all these objects that I just talked about. It could be either an ETL script or could be a stored procedure and things like that. Now, because the model was having these understanding augmented by the fine tuning that we did. On the process, we also have infused our own methodology. Like, for example, sometimes you might have some sequels written in a way that can be improved, like efficiency, or probably the constructs can be refined to work more efficiently. That level of logic also is something that we have used in our fine-tuning process, so that the model translation is much more better. Like how generally the human beings don't even go sometimes, be better than what humans could do. And the last part, which is the most crucial part, is to have the testing, robust testing done on top of the overall process. So once the migration is done, it's crucial to make sure that every object that is migrated needs to be validated in terms of syntax which is used, or the data which is what it's moving. So syntactical validation, data validation, and all this stuff. So again, we have used another foundational model, large language model, to generate these test scripts automatically, which will go and fire both on source and a target, and it will give you kind of like a report or probably a validation from both the source and a target system, and kind of like compare these two results and give you a report that, hey, how well the migration happened. So at the end, after the testing process is done, there will be a good overall migration reports gets generated, where you probably would be having a clear indication of, hey, how much has already been done and how much is probably may required. Actually, at the end of the migration, we see that like still there would be a 3 to 4 or 5% at max would be kind of like objects that might require a little bit of a human intervention. We are not at the 100% yet, but 95% is a really good achievement that we have done. And that's exactly what we're bringing up to the table by having this generative AI infused in our DBShift.